Hi, this is Mrs. Spohn, and today I'm going to show you how to write numbers in scientific notation and also how to go from numbers written in scientific notation and put them back into standard notation. And recall that scientific notation is an abbreviation for very large and very small numbers in science. In science, we have a lot of large and a lot of very small numbers, and we have to perform arithmetic operations with those. And scientific notation makes it much simpler. So how do we put numbers into scientific notation? And we have some numbers over here, and we're going to pretty much do all of these examples in this video. Scientific notation is some number written in the form of a times 10 to the b, and that might not make much sense to you right now, but we'll see what that means as we do them. The rule of thumb and the most important thing we want right now is that there's always going to be one non-zero number to the left of a decimal point. There are other ways to write numbers in scientific notation, but if there's more than one number to the left of a decimal, it's called exponential notation. So I'm gonna kind of be picking, just as we learn how to do it, we're always gonna focus on strict scientific notation that has one non-zero number to the left of a decimal point, and we're simply gonna move decimals left to right and count the spaces in between them. And the reason we can move decimals left to right, because any number in scientific notation, you're multiplying it by 10 to some power, times 10 to some number. And if you were to have a number like 221 and you were to divide it by 10, well, we assume there's a decimal point here. Dividing any number by 10, you're just going to move the decimal point one place. 221 divided by 10 is 22.1. And likewise, if you had 2.20 and you wanted to multiply it by 10, well, all you're doing is moving the decimal point over one place. That's going to equal 22.1. So scientific notation lets us express very large and very small numbers in terms of powers of 10, because multiplying or dividing any number by 10, all it does is move the decimal point in that number. It doesn't change any other values there. So when we move decimal points left, there's going to be for big numbers, positive exponent. When we move them right, it's going to be for small numbers or negative exponent. Let's do some examples. So I have the number 100, and I want to put this in scientific notation. There's kind of 4 questions down here. The first question we want to ask is, where is the decimal? And there isn't a decimal in this number, but that's because we didn't write it in. We don't write decimals unless we have to, but there is an assumed decimal right there, 100.0. Where do I want it? Well, the rule is I want one non-zero number to the left of a decimal point. I want one number, and it can't be 0. Right now, there's 3 numbers to the left of this decimal point, a 0, 0, and a 1. I only want there to be one number, and I want it to not be a 0. So I'm going to move this over one place, 2 places, and put it right there. So I move this 2 places to the left. I move to the left. So I'm going to write this number as 1 times 10 to, then how many places did I move it? 2. 1 times, let me read that, 1 times 10 to the second power. And that should make sense. This number is 100. What is 10 squared? 10 squared is 10 times 10, and that's 100. 1 times 100 is 100. It's the same number. This number equals this number, but it's written in a different form. So let's look at the number 1000. And we have the number 1000. And the first question is, where is the decimal point? Well, the decimal point's right here. We don't write it in, but it's there. Where do I want it? I want one number to the left of it, and I don't want that number to be a 0. So I have to move this over 1, 2, 3 places to the left. So I'm going to have a positive exponent. And I'm going to write this number as 1 times 10 to the third power, because I moved this decimal over 3 places this way. Whenever this exponent here is positive, it's because you had a number that's essentially larger than 1. We call it a big number, but anytime the number is larger than 1, the exponent's positive. And let's try another example, 24,000. 24,000. Again, I'm going to assume the decimals here. I want one number that is not 0 to the left of it. So I'm going to move it 1, 2, 3. I have 2 numbers to the left of it that aren't 0. I have to move it one more place for a total of 4 places to the left. And I'm going to write this as 2.4 times 10 to the 4th power. And this number right here is the same exact number as this one. It's just written in a different form. And if you were to multiply 10 to the 4th is just 10 times 10 times 10 times 10. And if you were to multiply all these out and multiply that by 2.4, you would get the same number. And again, anytime you multiply a number by 10 or divide it, you're just moving a decimal. That's the logistics of scientific notation or exponential notation in general. And let's do that other number there. 3, 6, 5, 4, 4, 5. Number 1, where is the decimal? Well, it's here. We don't write it in, but it's assumed to be there. Where do I want it? So there's only one number to the left of the decimal point. So I'm actually going to want to put this decimal here. So there's only one non-zero number to the left of it. So I'm going to move it 1, 2, 3, 4, 5 places. And I write that as 3 point, and these are all numbers I have to keep. 3.65445 times 10 to the 5th power. And that's how you would write that. And so the next one's a little bit of a trick. I have the number 2. Where is the decimal point? Well, the decimal point's right here. Where do I want the decimal point? Well, I want one non-zero number to the left of it. I have one non-zero number to the left of it. I don't have to move it. So if I wanted to put 2 in scientific notation, I would write it as 2 times 10 to the, how many places did I move the decimal? 0. And that's a simple thing, that 10 to the 0 power equals 1. So this is true in this case. So the number 2 in scientific notation is 2 times 10 to the 0. And now we're going to switch it up and we're going to do some small numbers. 0.001. I can't move the decimal this way now because I want one number that is not 0 to the left of the decimal. So I'm going to have to take this decimal and go 1, 2, 3 places. I'm going to have to put the decimal over here now. And I moved that 3 places, but because I'm moving in this direction, because I have a number that's less than 1, I have to write that as 1 times 10 to the negative 3rd. Whenever you have a small decimal number and you're moving the decimal to the right, moving right, we have a negative exponent over here. So this number, 1 times 10 to the negative 3rd, is the same as this number right there. And to do another example, 0.000001. The decimal's here. I need one number that is not 0 to the left of it. The only thing I can do is move it 1, 2, 3, 4, 5, 6 places. 6 places to the right. So that's 1 times 10 to the negative 6. Don't forget the exponents. That's what some of us are going to make mistakes on. So it is negative because you're going to the right. That's scientific notation. And we'll do the next one. We're right here. 0.00000904. Where do I want this decimal? Well, I only want there to be one number to the left of it. If I move this decimal all the way to here, I would then have a 4, a 0, and a 9 to the left of it. I don't want that. So I'm going to move this decimal 1, 2, 3, 4, 5 places. And I'm going to write that as 9 point, and I got to keep the 0. It's a placeholder for this 4. 9.04 times 10 to the negative 5th. So that's how we write large and small numbers in scientific notation. Now we're going to do 2 problems where we take numbers out of scientific notation and write them in regular form. And it's just the reverse process. It's the complete opposite. If I have a number like 5.03 times 10 to the 6th. If you want to put this in the regular notation, all you're going to do is move this decimal point over. And every time you multiply a number by 10, you move the decimal 1 place over. So I'm going to have to move it over 6 times. So I'm going to move it over 1, 2, and let me rewrite that. 5.03 times 10 to the 6th. We're going to move it over 1, 2, 3, 4, 5, 6 points. And I'm going to have to put a 0 in for each one of these moves. So this number would actually be 5,030,000. So we have to move that over like that. So that's how we get a number out of scientific notation. We have to go the other way. And we'll do a slew of examples in class. You'll have an assignment where you'll do something where it'll become like second nature to you. So this number is a big number. And if you're ever confused, you can pull out a calculator and put this in and change from scientific to standard notation, just not on my scientific notation test, because that's calculator free. So get used to doing this. And if we had a number like 4 0.3 times 10 to the negative eighth, you should know that there's a negative exponent here. This is going to be a very small number. So the decimal point is going to go that way when I put it in the regular notation. So 4.3, and I got to move this decimal point 8 places. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. So this number would be 0.000000043 or 0.000000043. That's what this number is. This number equals that. And if you were to put this number here into scientific notation, you should end up with that. So that's how we do scientific notation. You always think about where is the decimal, where do I want the decimal to be, how far am I moving it? Is it going to be negative or positive? If you have a number greater than 1, it's always going to be a positive exponent. If you have a number smaller than 1, negative exponent. Coming out of scientific notation, it's exactly the opposite for each case for positive exponents and negative exponents. It's the exact opposite. And now you have an assignment. Take these numbers and, oh, that's the next video. You're going to take these numbers, convert them into scientific notation. These should all have positive exponents. These should all have negative exponents, small numbers. And then I want you to take these numbers and put them into regular notation. This is Mr. Spohn. Hopefully that helps you write scientific notation. I'm out.